And I am live. That is pretty cool. So today is 16th of September 2025, Tuesday, and we have gone through and read the whole uh, chapter on dynamic programming from CLRS book and yeah, CLRS. And now the goal is to do some practice so that we do understand what we just read. So the theory part is over. Now we have to do questions. And one more thing, like someone like Benjamin Keep would say, we are practicing now, and then we will have to practice again, maybe after a month or 2 weeks. So first, we will do all the dynamic programming questions from the CSES sheet now, and then we will come back to these questions in maybe a month or two and then do them again, and that would be pretty cool. And there are a lot of questions left in the dynamic programming section of CSES, so definitely we are not going to complete them today. So at least it is going to take 2 days at least, yes, but 3 days I do not know, but yeah, at least 2 days. And with that intro, let's begin. Stop the video here and ta-da-da, yep, CSES, dynamic programming, and we begin with array description, whatever that question is, and next set attach TCS, yes, CDDB, ls, and yep, there are some updates in NewM. And this is the first question that we have to do. You know that an array has n integers between 1 and m, n integers between 1 and m, and the absolute difference between two adjacent values is at most 1. Given a description of the array where some values may be unknown, your task is to count the number of shit. You know that an array has n integers between 1 and m, and the absolute difference between two adjacent values is at most 1. Given a description of the array where some values may be unknown, your task is to count the number of arrays that match the description. Shit, so our array is incomplete. And then we have to find the number of ways in which we could complete that array, which and the arrays that we can form have to have this property. That is, the numbers that we fill in wherever the array is incomplete, they must be between 1 and m, 1 and m inclusive, and the difference between any adjacent two values is at most 1. Okay. The first input line has n and m, the size and the upper bound for each value. The next line has n integers. Value 0 denotes an unknown value. Print an integer modulus a million nine, a billion nine, a billion seven. Okay, shit, that is something. That is something. It is only the first question, and I think I have tried this before on a stream. Let's see. I have actually tried this before a stream. Let's see how much I have grown since then. Int n and m, c in n and m, and then vector integer a size n for int reference x in a c in x. We have the whole array. Now, okay, let's do some escalator. Okay, this is not the thing. That was something else. Yes, here. Let's go with this. Since we know in dynamic programming, there were 4 steps. Let's first just state those things. I am already feeling tense. So, number one, uh, describe the optimal solution and why is this moving to the left? That is kind of strange. And then second, uh, recursively define the optimal solution with solution to the problems. It is because of this left align. Okay. And then third is find the optimal solution value. Okay, so what is the optimal solution going to be like? Here we have n till equal to n is 3 since we have three numbers and m is 5. We can have in this array values up to 5. So well, in this case, we can easily write all the optimal solutions and they are going to be 1, 2, 2, then 2, 2, 2, where the difference is 0, and then 2, 3, 2. These are the only possible answers, but we do not want the possible answers. We need to find their count. And the thing is, when I am putting some value in unknown place, there are going to be some constraints on this value due to the number on the left and due to the number on the right. And given that, I have to find what I can do actually. But the thing is, I cannot here, if I am just looking from the left, I can here put 1, 2, and 3. I have three choices, but I also need to see are these choices correct, because these choices will give rise to some other choices which I will make if there were some other unknown values on the right, and only a few of them are going to be correct, and I need to find out if they are correct or not. So the difference in this and normal dynamic program questions that we have done till now is that here the choices that have been provided to us, they might be wrong. Like they might be illegal choices. We won't even be able to make them. So that is a problem. And here we have 0. We can possibly have here three values, and each of these three values which we could have here would give rise to 9, not exactly 9, but one limit up and one limit down, 5 new values that this value would take. And given that only a few of them are going to be compatible with this value on the right. So maybe what we can do is we can choose some. This doesn't even feel like dynamic programming, because normally when we do dynamic programming, we know that the choices that we are making are legit. We can know that beforehand. But how do we wait, shit, if a choice is invalid, we can just return 0. Okay, yes, that is one choice. That is one choice. That is one choice that we could do, one thing that we could do. So let's say, yeah, shit, okay. We can find, let's say we have a different array ZR which has all the indices which are 0. So I will go to anything, and if this index on the left, if this index is not 0, that would mean here on the left I have some value. Wait, yep. Instead of moving from the left, let's move from the right so that it would be easier to add and remove values into this vector, because adding and removing from the end is easier. So here we have this value. And if this index is not the last one, then the values that are possible here, the number of choices that are possible here are going to be this value on the right, +1 and -1. So here, when I am at this index 2 for this particular 0, I have a couple of choices, and the choices are: first choice, I could go with 1, and then second choice, I could go with 2, and the third choice, I could go with 3, and they do align up completely with the choice numbers, right? And let's follow one of these choices. And shit, I think we are directly defining the recursive solution, but we haven't described the optimal solution. And I'm trying to follow what we have read in a series stepwise manner. So, yo, hello, how was your contest yesterday? Mine was very bad, bro. How was your contest? Same. Yesterday I didn't give the contest. Yep. I started solving the questions, and like I saw the first question and I started to write some code, and then I just blanked out. Just my brain went out. I was unable to think somehow. I don't know why. Maybe I exhausted myself during the day doing something. So yeah, yesterday I didn't give the contest, and I guess I do not have to feel bad about it because I don't know. I think feeling bad is not going to help me. And yep. So yesterday I didn't give the contest, not even one. Shit. And here, yep. So these are the choices that we could make going from the right. And for each choices, we will change our problem and the number that is here. And how would we be able to, yeah, we would be able a recursion would be easier here. And let's say we have a function f that takes in the number of zeros. Uh, Initially, the number of zeros would be something. Uh, and since we are only coming from the right, this would only depend on the current number of zeros and only on the current number of zeros. And what is the value for this particular 0 that we have just changed, because that is the only thing that matters for all the subproblems on the left. So integer I, it would depend on an integer I or a recursive function, and integer I would represent how many zeros I am choosing from this zero index array vector, and also what is the value. Yeah, yeah, that is the thing. That is the only thing. And I do not have to look at the value. I do not have to explicitly send in the value in this function, but the function will change. It does depend on this. So zero vector. No, no, no. Int I think this should be enough, how many zeros I have, but also on the number, on that particular number that could be there. And the number of zeros in total could be n, and the number of values that could be there is m. And what are the constraints? M is at max 100. So if we do make a vector of this magnitude, I don't think we would need a vector of this magnitude, but in the worst case we will need a vector of this magnitude. Our table would be something of the size big O of n into m. Yep, n into m would be the thing. And I think a recursive solution would be much preferred here, in which the data structure storing the answer would be a mapping a pair of integers to a value. To a integer value. Mm. It was similar to prefix sum, but uh, yeah, you get exhausted. Yep, we do get exhausted sometimes. It was similar to prefix sum, but one with one extra mid sum as well. But today morning I saw top coders solution. We just need to do some modulus 3 for the first one. Also second one just 10 minutes after the one. That is crazy. Okay, let's try to do this. Using a recursive solution, we would need a map of pairs in, let's call it memo. And I'm here using recursion because the number of subproblems that I think we would have to solve using recursion is lower as compared to the subproblems we would have to solve using tabulation. So that is why I'm going with recursion here. And I think I have a good mental model. Okay, and for int I equals 0, I less than and I plus plus C in AI. And we need another vector ZR, which will have all the indices of the zeros. If not AI, then ZR dot pushback I. So we have the 0 vector and we have this, and this will return integer, and we also need for int m equals 189 plus 7 int solve, and this thing is just going to take an integer I. I think I should make the 0 vector global, so that this function has access to it, and this I will be the index of how many zeros are being used here. And also let's send in the vector A, reference A. Now if I uh, I equals -1, that is we do not have any zeros left, then return 1. That would be our base case. Else if memo dot count for this particular I, and how do I get, now it will depend if this I is the first 0 that we have or not. If I is lower than a dot, let's say int n equals a dot size, if I lower than n minus 1, that now I know that there should be some element to the right of this 0. No, that is that is not the right thing. If ZRI, not even that, not even that. If Z dot ZR dot size if I lower than ZR dot size minus 1. Yes, that is, I have some other 0. I have some other 0 to the right of this one. Yes, so this is not the first 0 that I have, and I have already filled up some 0. If this is the case, then I will look into my map, memo dot count I, comma, the value of that 0 which I have already filled up, which is going to be in A array, ZR I plus 1. ZR I plus 1, I is 0 indexed. I is 0 indexed, that is why I am checking here minus 1. If that is the case, if I already have that, then return memo bracket I, comma, A, ZR I plus 1. Yes, this is what it will depend on. Else, if we do not have it, then something. Then we need to see what values could be here. Yep, what values could be here, and we know here that this is not the first 0. So there must be some value to the right of this thing. So there are 3 values possible here. So we will be calling the solve function 3 times. Yep, int res equals initially 0, and then let's first put a bracket ZR bracket I equal to a bracket ZR bracket I here plus 1 minus 1. Yes, and res plus equal to call the solve function with I minus 1 comma with vector a. Yes, yep, yep, yep. And then res plus equals solve. Let's make this long. Let's make everything long so that we are happy. Substitute integer with long globally. Well, let's make a change here also. And long globally with res plus equals. Yes, we got the first answer, and then res. Yes, now with the next value for this thing, I think we can use a for loop here. I equals minus 1, I less than 2, I plus plus. Not I, not I. We cannot use I. I is already being used. So z x take remainder with m and plus x. Wait, shit. Plus 1 plus x. Now we have the answer, and we can put it in memo bracket I, comma, a x z r I plus 1, whatever the value was for the next 0. Yes, but when we are at the first 0, and if that is the last 0 possible, then we will have a special case. Yeah, which, yeah, yeah, we will have a special case for that. And it is also not going to be solved. It is also not going to be solved by this. Yep. Yep. Let's put it here. I for this index A, Z R next 0, whatever the value of that next 0 is equals this. And then return this. Okay. Okay. That part I think is correct. Else without the underscore. Hello. Shit. My bad. You were right, bro. These educational rounds are hard. Yes, these are hard. They are designed that way. Bye. And I have planned that after I have read more theory and I am very well versed with the theory, then I would give virtual contests in the educational rounds for educational rounds, and that would be pretty cool. Virtual contests. I guess one every day would make me very comfortable with giving contests, but it is not here. Now I have to practice. Yeah, this. Okay, so if we are at the last 0, we would have to see how many possible values can that 0 have. So int L and R for the left limit and the right limit. Now, if the left limit, if this 0 is not the last thing, if ZR I is 0 indexed, if ZR I is lower than n minus 1, that is, there is some actual numerical value to the right of this 0, then left limit is going to be a bracket ZR I, the index of that 0 plus 1. The left limit is going to be minus 1, this value, and R equals plus L plus 2. That would be like minus 1, 0, and 1. Yeah. Else, if that is not the case, if 0 is, if the index of the last 0 is the last element, then L is going to be 1, 1, and R is going to be equal to M. But I do not know what M is. Shit, I do not know what M is, and I am blindly here changing the values. So M and L, also M has to be a global variable. My bad. So first of all, we will make the change here. R equals M, and also let's fix this thing up. Since we are always moving upwards, if the value that I'm setting, which is going to be a ZR I plus 1, the value to the right of the 0, plus x, not minus x, plus x, and v equals a ZR I plus 1 plus x. If v is greater than equal to 1 and v lower than equal to m, then call this function with v. Give the value of v to this 0, and before giving that, confirm that this value is a value that is possible. And what is V? V is this thing. Okay, cool. Yeah, cool. And after this, here, now we will have for int I, no, not I, int x equals L and x lower than equal to R and x plus plus, and the 0 in question is the rightmost 0. Let's first see if x is a correct value. If x greater than or equal to 1 and x lower than or equal to m, only then call the solve function. And before actually doing that, a bracket zri, put the zero's value equal to x, and then solve the function. But before even that, long rest initially equals 0 and rest plus equals solve I minus 1, solve I minus 1 with a, and then rest percent equals m. Take the remainder of rest with m. And after we have gone through the whole thing, we do not need to put this into memo because we will never need this. So we do not need to put this into memo. At the end, we would have to return something, right? Yes. Let's rest equals 0. Return res right from here. Nope, we can avoid that and do this here. And we do have the value for res. And before returning res, we are putting it into memo. That seems correct somehow. Okay, let's see if it is actually correct. Solve zr dot size minus 1 and a. Long rest equals whatever is returned, new line. Okay, one is wrong. One is wrong. One is definitely wrong, and one is definitely wrong. And we should be going inside this thing. And when the function is called with this given input, we should be going inside this statement. Yeah, in here, and our left should be equal to 1 and our right should be equal to 3. So let's see what they are actually equal to, and if we are going inside this function call or not. We are not going inside this. Why are we not here? Here I'm saying I is lower than res dot size minus 1. Yes, res dot size is 1. Res dot size is 1, and we are calling I. If not AI, then a. Yes. What is the mistake? Okay, one is correct. One is absolutely correct. So that is also the size. So we are calling this function with 0 as the input. Yep. I is equal to 0. So we do not go into this statement and we do not go there. We can use printf debugging, or I also have access to LLDB. But now I'm using G++, so I cannot use LLDB with that. I would have to learn GDB. I lower than res.size minus 1. No, that is not true. So therefore, we should have come in this statement. But why didn't we? Okay, we didn't come into this statement due to some reason. I are we not even calling this function? Solve zr.size minus 1, and zr.size is 1. So we are calling this with 0, and a zr.size minus 1. 0. Yes, we are calling this function with 0. And if we are doing that, why are we if I equals minus 1, then return 1. So we should be getting this output somewhere, but we are not getting this output somehow. Okay, yes, shit. We didn't get this output. When this statement was there, we did got 0. But when this statement is here, we are not getting any 0. Why is I returning? I said I equal to minus 1. Okay, okay. See out I with a new line 0, 1, and 3. AB is some application binary interface error, something like that. And see out ZR, not ZR. So now we know that we are getting into this thing right here, and let's see the values for these two, left and right. That would be nice to have. Here, left and right are 1 and 3, which is correct. And we are not getting any error before that point, so that is nice. But after that, we are getting some error. Why? See out L space R, left and right have correct values. That is true. Int x equals L. L is 1. X lower than equal to R. Okay. And if x is greater than 1 and less than equal to M, then put that value in this equal to x. Yeah. And then call the res function for I minus 1, which would return 1, and take the remainder. So what is the problem after this point? Wait, are we getting the error because of this? I don't think so. Yes, 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 because we do not have enough zeros. Yes, makes so much sense. We do not have enough zeros. So we do not want to do this step here. Instead, we would like to do this here. Memo is only useful there. And now we should be getting some beautiful answers, except maybe not. See out L space R and then the line. L and R are 1 and 3. So this should be returning 1, and all of them should be returning 1, but no, they are not somehow. See out I, how many times is it being called? It is being called a number of times. That is good. So why aren't we getting any answers? Okay, now we go, now it works, but why wasn't this thing? Ah, my bad, my bad, my bad. I was defining res internally at a place. Okay, now it is good. Now it is good. Now it is working. And I think this should be correct. I think this should be correct. This should be correct. We will just have to see if it actually is. But before submitting this, like good programmers, what you have to do is delete this whole thing and write code from scratch again, like good human beings, like good programmers do. And yes, we are using recursion for this because recursion, I think, is going to save us a lot of subproblems that we do not have to solve. So that is why recursion is being used here. Int m and pause int m equals 1e9 plus 7. And do we need something else? Yes, we do need vector of integers. We will call it 0. And the size we do not know just yet. We do not know it. And vector of integers a, the size is going to be n, and for int I equals 0, I less than n, I plus plus, we will take in the current value in ai, and if not ai, then add it to 0 dot push back the index on this thing, and above we will need some data structure for our memoization. Int pair int we will call it memo, and our function which will return a integer, we will call our function solve, and it will take in an integer, and it will take in a vector of integers, a reference a. And now if I equals -1, then return 1. That is, we do not have any zeros left. But if we do have some zeros left, then we would have to check stuff out. And yes, then we would have to check stuff out. And what would that stuff be like? First of all, we have to see if there are any other zeros left or not, or if this is the first zero, right? So for that, if I lower than zr dot size -1, first of all, that. And let's also do int n equals a dot size, so that we have that thing in handy. If this thing is not the first zero that we have had, if this thing is not our rightmost zero, then there must be some zero that we have already set up. So we will look into our memo if we have already solved for this zero. So if memo dot count for this pair I, and the value, the answer depends on the current number of zeros that we are seeing, and also the value that was given to that last zero, which is not included in the list, and that is going to be in the array A currently, which is in the array A. Mm, mhm. Yes, currently which is in the array A, and the index is going to be the index of that last zero, which was Z. We minute, what if we have different chunks of zeros? I think it is not going to cause any problem. It is not going to cause any problem. We can just move on with this. Yes, 0 I, the index for the current 0 plus 1, the index for the 0 that has been excluded from our society. Yes, if we have already solved for it, then return memo bracket I comma a zr I plus 1. Yeah, that is kind of cryptic. Let's say I cz is the index for the current 0, which is zri, and int nz is the index for the next 0, I plus 1. So internally we will have nz. Have we already solved for this? And if we have, then nz returned. Else if we haven't, then we need to see how many possible values this current 0 can have, and it would depend on the value that is immediately to the right of this current 0. So for int I equals -1, I lower than 2, I plus plus, and the current value that this 0 could have would be v equals a current 0 plus 1 plus x. Yes, we cannot use I here. This is the value, and if this value is in range, which means if I greater than equal to 1, if v greater than equal to 1 and v lower than equal to m, it is a valid value, and we can call the solve function for I minus 1, giving this value to this 0 and a, and we give a current 0 equals 0, and we are calling this function, right? And at the end we can say a current 0 equals 0, so that every change is reversed. And also, not just simply this, we will have a long response there, which is initially equal to 0, and here we will have rest plus equals listening and rest remainder with remainder with m, capital M. Okay, so for the current 0, we are seeing all the valid values that this current 0 could have, and if this value is valid, we are putting that value to the current 0, and we are calling the solve function with one less 0 and giving our array also, and then we are adding its response to our response, and we are also taking the modulus. After this for loop, we return 0 to its whatever the value it had before, and then we have to put this in the memory and then return this. Memo I, comma, A and Z. The value would depend on the next 0. Yes, the value would depend on the next 0 and it is equal to res and then also return res. Else, if this is the first 0 that we have seen in a long time, if this is the first 0 that we have, then we will have some integers left and right. And if if this 0, since this 0 is the first 0, we have to see, is this 0 the first element in the whole vector, the rightmost element in the whole A array? If I lower than n minus 1, this would mean it is not. Then L would be equal to, let's also have current 0 and next 0 here, so that we can use them there also. L would be equal to A current 0, the index for the current 0 plus 1 minus 1. This is going to the least value that this could have, and R would be equal to L plus 2. Else, if that is not the case, then L is going to be 1 and R is going to be M. And now we will run our loop for in x equals L and x lower than equal to R and x plus plus. Now, if this x is a valid, if this x is a valid value, that is x greater than equal to 1 and x lower than equal to m. If this x is a valid value, then we will call the solve function, but before calling solve function, we will put current 0 equals to x, and then we would also like to have a long response right here, and response plus equals solve n I minus 1, use 1 less zeros, and a is our vector, s equals m, and then return rest. And here we do not have to store this response into our memoization because we are not going to need this ever again, because this is standalone. There is no 0 to the right of this thing. So this is standalone. And I hope this works. Wait. First, we will have to call the function here. Yep. Long res equal solve with zr dot size minus 1. That is, we are using all the zeros, and zr dot size is one index. We need to return the index of the 0 that we are using, not index of the 0, but how many zeros we are using, minus 1, and a, and then see out. Okay, this might work, this might not work. We will have to see. AB, that is messy. Why do we get this error? NZ, this NZ thing, it makes sense. NZ was the only thing, and okay, it is giving us the right answer here. CDDP G++. array description backslash out, and let's say our n, we have four numbers, and our m is, let's say, 5, and the numbers are 2 0 0 2. Let's see manually what the answer should be. And if we do actually look manually, the answer, the possible values, this is our input. The possible values could be 1 1 2 2 1 2 2, and yep, now we cannot increase this value anymore because this is 1. So 2 1 2, and 2 2 2 2, and then 2 2 3 2, and also the upper limit 2 3 3 2. That would be kind of it. So in total we have 3 plus 3 6. Answer should be it is 8. Okay, so we messed up. We somehow messed up. Let's actually see what the values are that we are printing here. Okay, here the answer that we got. Why are we calling this function with 0? 0 is not a valid value. This is because of the first function call. Yeah. Okay, yes. That makes a lot of sense. So if I equals -1, then first of all print the whole mess. This is like BFS. This is like DFS. Shit, I'm not fixing my changes. I am only fixing my changes later here. So something is wrong. Return 1. C++ 4 and 5 2 0 0 2. And these are the inputs. Okay, 4. Yeah, shit, I messed up. I'm not looking at the value on the left. My mistake. Okay. 1 2 2 1. Yes, all of these are correct. All of these are correct. Wait. 1 2 2 1 1 2 2 2. I am double counting. No. This is correct. This is not double counting. 2 3 3 2. Yes, okay. I messed up. I didn't 1 2 2 1 2 3 3 2 2 3 2 2. Yep. So the actual answer should be 7. This is the wrong one. This is the wrong one. So when I am putting some value, it depends. I have to check with the right, with the value on the right, which I am doing here, but also with the value on the left. But also with the value on the left. And if on the left I have a 0, then any value is workable. But if not, then no. And yep, I am putting values here and in the next else statement. So, but I do not want to put that much logic into a single if condition. That would be too much logic here. A little function, maybe a little functor. maybe I can use a little functor. Yes, shit, that would be actually pretty cool. Okay, or class called correct, and this will only have a single operator. No, this will take in a number. This is going to store the state in time. This is public and I with I, yeah, and then bool operator. This is going to take in a single value, the current value that I'm trying to get, and this I is going to be the index of this current 0, let's say. And yeah, and a vector reference to integer is ZR. I would also need A, yeah, not ZR, but vector reference A. And X is the index. X is the value of this current 0. Now, if I is 0 and there is nothing on the left, then return true. Else, if I is not equal to 0, there must be some value on the left. So, return A bracket I minus 1, absolute value of X minus A bracket I minus 1, where I is the index and X is the value. This thing, absolute difference, is lower than equal to 1. Yes, lower than equal to 1. Just return that. Lower than equal to 1, and also this must be in the limit range. So let's say this also takes in M, but every time, do I have to give M every time? No. In M, I can just give it once in M, and I think this is over engineering. But anyway, wait, I don't think we need these. We will get some error. LSP start plan D. Okay, there is a mistake. Operator integer X, LSP stop. Now I also have this, so this thing must be true, and X should be greater than equal to 1, and X should be lower than equal to M. And here I know the index for this 0, which is CZ. and I also know the m. So I can use the same operator here. Yeah. Uh, auto or wait, what is the name? Correct or valid might be better. Valid, okay, equals new valid equals valid I and m. Okay, valid I and m, and inside this function I have to call okay. I am checking if x is okay, and with x I also have to give the current value of a. And is the value of a changing? Okay, it is okay, it is okay. Value of is not changing, so we can take a also here, vector in reference a, let's call it a, and this will take a vector in reference a, and here dot a with a, and inside we do not have to take in any of these, we just need x. Is x okay? If x is okay, then we are okay. Okay x, if okay x, then okay. And then here also we will do the same thing. If x, if okay x. Is the LSP giving any errors? Okay, it is giving some errors at some place. Here valid, why do I have to use new? If I have to give a. Public valid, it takes in wait, what is wrong with this? Okay, my LSP broke. Now it is okay. LSP V star. Okay, cool. Everything is correct. Everything is correct. And G++ dot slash out 4520002. Okay, now the answer is 9, which is even more bollocks. Yes. 9 is not correct. 9 is like absolutely not correct. And we are even calling this for 0. How is this function returning true? If I equals 0, okay, if I equals, if not I, then return x. X has to be greater than equal to 1, and x has to be lower than equal to m. G++ dot slash out 4, 5, 2, 0, 0, 2. 3. That is not right. That is not right. That is not right. Wait, this has we see that. G++, compile this again, and 4, 5, 2, 0, 0, 2, and this is even worse than ever before. Shit. Uh, so why is this function messing up? X minus the last, and we also have to see if what the last number is. Yep. So if a I minus 1, if a I minus 1, then this. Yeah, if either I is 0 or if I is not equal to 0, if either I equal to 0 or shit. If this thing would be false, then we would go in. Yes. I minus 1, not. And when this thing is false, only then we would go here. And when this thing is false, that would mean I is not equal to 0, and we can do a I minus 1. And then always we will do this. Okay, at least we are getting the right answer there. /out 4, 5, 2, 0, 0, 2. 3 is not the right answer, unfortunately. 1, 2, 3. 1, 2, 3 is absolutely amazing. But 2, 3, 4 is not very cool. 2, 3, no, 2, 3, 4 is not very cool. If this current 0 is not the last one, if this current 0 is the last one, last 0, or the number before it is also a 0, then only its face value matters. Yes, otherwise it would mean that this is not the first number in the series, and also the number before it is not a 0. So if I take difference of this current number, the value that I'm choosing, and the value before this, it should be less than equal to 1. The difference should be less than equal to 1, and also 0. X should be in the specified range. So what is wrong? Instead of this, I should, I guess, write a function, Boolean function. And this function depends on the current value. The index m is like global, so anyone can access m, the current value of x that we are trying to put. the current index for x, and a. And here we have everything. Yep. And we will call the function. Okay. Yes, okay, okay needs a few more arguments than this. Now, since it is a big function, it will take in CZ, the current 0, and A. 4, 5, 2, 0, 0, 2. 3 is what they say. 3 is not correct. 3 is absolutely not correct. So when we have 1 here, the possible values for this thing, 2 is a possible value, but 1 is also a possible value for this. So why are we going straight up to 2? That second function call would end up in this, because I would be equal to 0 and SZR dot size is 2, 2 minus 1 is 1, and the next 0 would be I plus 1, which would be 2. So NZ would be equal to 2, and we do not have the answer till now. So we go down, and response equals 0 and x. Now it is working because I messed up. Shit. Okay. Now it is correct. Now it is actually correct. It is working. Okay, now we have to submit and see if it is correct or not. Shit. Okay. And I've spent a long time, more than an hour on this single question after spending 3 days on reading up on dynamic programming. CSES dynamic programming DP. This is array description. This one, C++ 20, and let's see. That is very bad. Even a time limit exceeded error. Okay, there is some compiler report. I less than zr dot zr dot size y input int solve function y, because there's size size will not be equal. Ah, no, that is taken care of. That is taken care of. So we do not have to think of it. When size is 0, 0, then we will call the first function call to solve with a value of -1, which is handled right here in the first line of solve. So that is cool. But why do we get wrong? 0 is not something that we would be outputting. 0 is certainly not something. No, no, no. Why do we output 0 on G++ dot flash out? this whole thing. Error. Huh. Why? LSP start plan D. Is there some LSP error? No. LSP is saying everything is amazing. Uh-huh. LSP restart. LSP is saying everything is amazing. Homology. STD vector allocation reference. Okay, I don't even see which line is messing up. If something is wrong with one of the vectors somehow, let's use some print statements and see till which I are things going fine. G++ array dot slash. Okay, compile dot slash out and 10.3.3.3.0.0.0.0.0.0.0. Hmm. We call this for I equals 6 and 1, 2, 3, 4, 5, 6, 7. We have 7 zeros, so the last one would be indexed 6, and then we see an error. So how far along are we going into this thing? Okay, this will be our first one here. Let us compile dot slash out 10 3 3 0 0 3 0 0 0 0 2 0. Okay, we are inside this thing. That is also good. And the left limit and the right limit should be different. Here, I is equal to, I is not less than n minus 1. I is equal to n minus 1. So left should be equal to 1 and right should be equal to n. Right. And then current is current 0. These are the values that it could have. See out L, the value on the left. See out R, the value on the right. Just compile dot slash out 10 3 3 0 0 3 0 0 0 0 2 0, and we do not get the left and right values, so we are messing up inside here, and we have to use CZ here. I messed up big time. CZ because that is the index of the current 0 and the thing that we are going to be accessing in here. Yep. I messed up that. 10 3 3 0 0 3 0 0 0 0 2 0. Okay, 348 is that the correct answer? 348, that is the correct answer. So if we go and submit this again, time limit exceeded. That is scary. Pending. Okay, time limit exceeded, time limit exceeded, time limit exceeded. Can we make this faster? Can we make this faster? I think if we use a table, that would be okay. If we use a table instead of this map right here, and because this map is might be taking a lot of time in test number 16. How many numbers are there? Because if we do not, okay, let's see. If we do use a table, then we will have n at max equal to 10 power 5, and we will have this is m at max 100. Yep, this is what we will have. But a lot of this is going to be empty, but it is going to save time on the cost of memory. So in total, we will have 10 to the power 7 integers, and one integer takes 4 bytes, right? 32 bits, 4 bytes, and 10 to the power 7, 10 to the power 7 integers. I should already have known this. 10 to the power 4, we have 10 to the power 7 by 7 into 4 bytes. Now we have 4 into 10 to the power 7 kilobytes. If we take 3 more from this, so 10 to the power 40 MBs. 40 MB is something we can handle. 40 MB is within the range. Yep, we can use up to 500 MBs. So 14 MBs is within the range, and we can remove this. And we can say constant n max is 1E5, to be specific. Yep, 1E5, 1E5 plus 1, because just because. And constant m max is 101. And then we will have a vector of integers. We will call it tab as in table, n max rows, and the number of columns is going to be m max. And we are going to change our lookup here. And initially every value is 0. So if a value is non-zero, then we have the answer for that thing. I is the index of the 0. So CZ is a lot of space is being wasted in this. Let's just bear with this. NZ next 0, the value for the next 0. If this is, then return table current 0, index, and the value for the next 0, which is A and Z. A and Z. Yes, that is how it works. The row number represents I, the index of the 0, the index for is 0. Okay, yes, yes, that will work. Yes, that will work, that will work, that will work. And then here, before returning, tab current 0 index with the next value as nz equals response, and then return the response. Okay, okay. Is it even working? No. Why? Because what syntax is this? This does not make sense. Now it is okay. Okay, 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 okay. Hopefully. Let's see. Submit. Array description. C++ 20. Submit. And what happens? Okay, I'm still getting time limit exceeded error. Even wrong answer. Wrong answer does not make sense. Time limit exceeded error does make sense, but wrong answer doesn't. If I have something like this, shit, they cannot give me something like this. Time limit exceeded. They cannot give something like this. Okay, let me check for this too. Yes, after getting the array, let's have bool p equals true, and for n I equals 0, I less than n I plus plus, and I less than n minus 1. Now, if the current number ai is a number and ai plus 1 is also a number, then if absolute difference of ai minus if absolute difference of ai minus the next number ai plus 1 is greater than 1, then p equals false and safe. If p do all of this, only then else cout 0. Long line res equals 0. Don't have to define it. At least I won't be getting a wrong answer now. Time limit exceeded is one thing that I want to avoid. Yep, now time limit exceeded is the only error that I'm getting. And optimization. I need to optimize this thing in some way. But before that, I have to figure out why is this not optimized already? Is the tabulation not helping at all? Because I'm not filling everything that is in the table. So that is a good thing. And even if, wait, is this function being called more number of times than it needs to be called? Current z a nz return tab e nz, whatever the value is for the next z. Time limit exceeded is the only error that I'm getting. We can, I guess, optimize this later, but shit, I was even unable to do even the first question in dynamic programming section after reading upon dynamic programming for all of these days. Rectangle cutting, minimal grid path. Let's maybe do a simpler one. Money sums. Let's try to do that. You have n coins with certain values. Your task is to find all money sums you can create using those coins. Ah, okay. Okay. The first integer input n, the number of coins, and then x n values for all the coins that are there. S- That is like generating all the permutations, not permutations, but all the subsets. Yep, all the subsets, and this should be easy, hopefully. Int n, c in n, and vector int. Let me turn off my LSP. LSP stop. Vector int a size n. Or let's call this c as in point for int I equals. I just need a point for int reference x in c in x, and now the maximum sum that I could have is when I have all the coins equal to 1,000. That would be, yeah, let's have a boolean value, a boolean vector bool, vector of bool, and pos as in like is it possible or not. And here let's have n max is 1e5, n max is 100, and int c max is 1,000. Yep. And that is the maximum value that could be possible. So n max into c max plus 1. And now when I'm only using a subset of coins, let's do this properly. Let's define this recursively. My function will take in the set of coins that I am using c. C, that is the set of coins that I am using. And shit, this problem was exactly there in CPHB Competitive Programmers Handbook. The set of coins that I am taking, take that in, and given that I have to fill my table. In my table, okay, let's properly do this. I have these are the coins that I could use. Let's say I have a table. When I'm only using this one coin, then the possible sums that I could have is 4, is two. There are two possible sums I could have. And with this, either I use this coin or I don't use this coin. When I do use this coin, then the possible sums would increase from the number of things to which I would have to add this coin would be 2. So the number of operations for this was 0. Number of operations for number of operations for this one was 0, and number of operations for this, when I do include this, I'm not using dynamic programming, am I? This is kind of like brute force, almost like brute force. Shit. But wait, if I keep a vector of all the possible sums whose maximum size can be 10 power 5, I will be doing 10 power 5 operations for all the coins. There are n coins, n into 10 power 5, 10 power 7, which is borderline doable. Which is borderline doable. But I would need a set and not this thing to store all the coins. Set of integers, unordered set of integers, call this S. How do I reserve in a set? C++ reserve uh, space in a set, unordered set. Reserve in unordered set. C++ unordered set dot name dot reserve this much s dot reserve n max into c max. Yep. And then I will go through all the elements in the vector for int I equals 0, I less than n, ni plus plus for all the coins. For this particular coin, I might include it or I might not include this. And set dot insert 0 when I do not use any of the available coins, then this would be the answer. So insert A0, C0, the first point. Let's start. Insert 0 when I am not using any points. And the next thing that I get, I will have to store it in a vector, and creating a new vector and then removing all the elements from that vector is fine. It's fine. I can do that. Vector int nw new values would be, the size would be n max into c max reserve this much size plus 1 just for safety, and int till equals 0, and then internally for int or auto x in the set s, nw bracket till plus plus equal to x plus the current coin, which is going to start from 0, x plus ci. Now till is pointing to the place where I could have that, and now I need to insert all of these elements into the set. After going through them once, I will have to add all of these elements to the set. So can I do set dot insert with a range? That would be nice if I can do that. Keep up, bro. Yo, hello. How is everything going? Yep, I will keep up. Everything amazing. You have now qualified for the regionals. That would be cool. That is cool. And uh set insert shit in C++. What are all the possible ways to insert in a set? Can I give it a range? If I can, it would be very nice. Iterator position. C++ 11. First and last, and okay. S dot insert from nw dot begin and nw dot end, not end, nw dot begin plus till. And then let's see if I am at least getting the size right. See out s dot size unordered set integer is s dot reserve. S was not declared in this scope. Unordered set lsp start clang d. What is the mistake? What else do I have to give to a set? That is it. Right. Unordered set. lsp restart. It doesn't work. Hello, I just got to know that set doesn't have constant time lookup always, like I wrote the code when I, yeah, the normal set uses log n time. Yeah, amortized. Unordered set is amortized, constant with no collisions. Worst case is n dot hash and map is log n. Yep, same with unordered set and set. Yeah, I used unordered set. I read that it's constant and amortized one provided you have no collisions. Yep, amortized time is constant, and to like get really a constant time, I'm using a reservoir, and I will not be using any more space than this. So this is going to be better, I think, at least. But unordered set, this is giving me error somehow. Too few template, what else does it need? And like my LSP is also broken. Money sums. LSP is broken. Shit. LSP start client D, unordered set. It needs class value, and I am giving it an integer and s. Okay, reservoir is nothing. Reserve is something. So no error now, hopefully. That is the correct answer. Okay. For auto x in s f x, then c out x with space, c out. And do I have to output in increasing order? Ah, shit. Then vector, and I will put all the numbers in a vector. Let's call it res with s dot begin and s dot end, and then sort res dot begin, res dot end, and then for int I equals 1, I less than res dot size I plus plus. I am starting from 1 because there is also going to be 0 in the response, which I don't want to output. I equals res dot size minus 1. Why twice? Because of this. Okay. C out. After I do have res. C out res dot size minus 1. Okay. Okay, that seems to be correct, but this might give me constant time, time limit exceeded error. No, it is not dependent on array size, it is dependent on hash collisions. Yes. And also whatever possible, you are better off using an associative array. Hmm. Yep. But is it always better to just go with the associative array? Because here I think if I reserve some space for the unordered hash set, I think this might be good. Yes, because the time complexity, the number of times that this thing is going to run is 10. Wait, no, it is not that big. It is very big. It is 10 power 7. 10 power 7. This statement in worst time can run in 10 power 7 times. So I want this axis of this thing to be better. But I guess this should not be very bad even if I do use a normal set. Let's see. Let's see. An associative array might also work here. I mean, I do not know if this is going to work. Non-associative array. Mm, money sums. 20 submit. Okay, shit. Okay, okay. I'm very happy. I'm very happy because I was trying to do that other question for more than an hour and I was not able to do it. I am a very happy man right now. Okay, let's now do some experimentation with this, and I will not use this, and let's make this a normal set and remove the reserve. And since this is a normal set, we don't need this vector and nor this sorting and none of this. Cout s dot size -1, and for int x in s, if x, or we can do this s dot, wait, here we can do s dot erase 0 and just output the size and cout x with a little bit of space and a new line. Okay, that is correct. And let's submit associative array with the associative array. And hopefully this works. And this works. This actually seems faster. Here in the worst case, in this one, it is taking 2.39 seconds. Submit, where can I see my all of my submissions? Here, statistics, analysis, results. See, the one with associative array is taking longer. Yes, this was the one that was submitted later. The one with the associative array is taking longer. The associative set is taking longer, but the one without the associative set, like normal unordered hash set, is faster because I reserve some space there. So that is one thing that is cool, but it does not work generally. It is only working here. And now analysis. I'm very happy that it worked. Okay, cool. To solve the problem using dynamic programming, define the function possible is to describe whether it is possible to form the sum. Okay, to form the money sum s using sum of the first I coins. Okay, when I am only using I coins, then do this. Yes, but that is not what I do. I have some other approach when considering the next coin. Wait, I am not even using dynamic programming. This is just brute forcing. This is literally brute forcing. When considering the next one, we can either choose it and add its value to the sum or not and only use previous coins. So possible I is okay, and okay, if this thing returns true, then add this. The symbol V represents or. I'm reducing this coin, and in this case I didn't use this coin to reach this sum, and in this case I did use this coin, and the base condition would be 0. If s equals 0, then return true, otherwise not. When no coins have yet been considered, the only possible sum is 0. This shouldn't be printed in this problem though. Since the recurrence only references computed values of the previous coin, it is enough to share a one-dimensional array as long as it is iterated in a suitable order. The time complexity of this solution is n square x, where x is the maximum value of each coin, and n can be 100 into 100, 10 power 4, and x is 10 power 3, 10 power 7. That is also the time complexity of our algorithm, which we are using. Okay, and well, this code is shorter than this code. Let's write that one. So we have to define a function, not that we actually have to define a function. But yeah, uh, the value for this thing depends on if we are in a table. So yes, because unordered is n plus hash worst case. Hmm? Unordered set in worst case, yes. And here, since I have already given the size using reserve, so that is cool. We can start iterating from I smallest to greatest and S also from smallest to greatest, and we can keep filling the vector. Yep. And I think we can keep I in the outer loop or S in the outer loop, and it does not actually matter what is in the outer loop. So int n, c in n, and vector of integers a size n for in reference x, a c in x, and vector for answer, the table tab, and rows would be the coins, or rows would be the sum, the maximum sum. Cost in n at maximum is 100, I think, and x at max, yeah, n at maximum is 100 and x I is 1000. Cons int c is 1 each. Stop the LSP. Uh, and therefore the sum is going to be maximum sum. This and vector int n, the number of coins, which is n, n plus 1, let's say. So for int, we will start iterating through coins int I when we are using this number of coins from the start. 1 I less than, let's make this 0 indexed, that is better. I less than, and we would also need a set. No, we don't need a set. We can iterate through the list that we made. This is going to be a vector bool res size is n into c. I less than n I plus plus, and for int sum, sum is going to go from maximum to minimum. Maximum to minimum, and the maximum sum int mx is n into c. I might be messing up this totally. The maximum sum is mx, so int s equals mx, and s greater than equal to 0 and s minus. And is my base condition filled? When s equal to 0, since the sum is the row, I have to make all of them true. So it would be better if I change this order, mx. In the rows, I will have the number of coins, the index of the coins that I am using, and there is no case when I'm not using any coins, so we do not have that, right? And then internal, yep, and then also fill tab 0 dot begin tab tab 0 dot end, fill this with true or 1, does not matter. Yep. And also, what is that code there? Boilerplate. iOS sync with stdio false. Do not sync with stdio. And C in null pointer. This is not actually needed in most of the cases. iOS std sync with std false, std io false, and C in tie null ptr. Wait, maybe I messed up. C in tie null pointer dot tie null pointer. This should make it a bit faster, okay? And here for 0, shit, it was better before. It was correct before when this was mx. So when the sum is 0 in the table, put everything equal to true. No matter how many coins we are getting at, it will be equal to true. Now we don't have to go to sum 0 because that is already filled. Now with the current values, tab sum and current coins that we are using should be equal to, if I use it, s mine, and also since I is the coin that I'm going to use, this s greater than ai, greater than equal to ai. Yeah. Tab s I equals tab S minus AI if I did use this current coin, I minus 1. What if I is 0? Yes, that is a very good thing to say. What if I is 0? If I is 0, if I'm only using that 0th coin, maybe I should, in that case, make this n plus 1 so that I is the number of coins that I'm using and not the index. If I'm using I coins, I is the number of coins. So this plus tab S when I do not use this Y plus or uh, or tab S minus. I'm not using this current coin right now. Just this. Wait, shit. Then I don't even need this res vector. I don't need this res vector because everything should be filled when I'm using all the coins in that vector which is there. Everything should be true. Yes. So now I can, but before outputting the actual answer, I need to output the count. So putting this in a vector would be nice. Res size is mx. Am I getting any errors? Yes, I am getting some error here. Why? Tab bool because yes, bool, bool. Restart. Yes, okay. For int I equals 0, I less than sum. I is going to be, so we can do s and s less than equal to mx and s plus plus, and we will iterate tab n. So if tab n, if tab n s, if it is possible to you to get to this sum using all the coins, then this dot pushback. Let's dot pushback s. Let's dot size and yes, for in x int x in res out x with some space and one. Or maybe a bunch of errors. Because this has There's some error there. Yes, while s is greater than a I minus 1. Okay. Mx maximum vector Boolean the number of rows is the maximum sum that I could have. Yes. And why am I going from big to small? A I minus 1 while s s is lower than equal to max mx. S plus plus. And I is n at maximum. At max, I is equal to n. Some part of this is giving some error. It's like it doesn't even make sense. Standard error. Is that the thing? Okay. Yeah, fill tab 0 when the sum is 0 till end. Let's be start blank d. Okay, there is no error. LSB start blank d. LSB restart. LSB restart. LSB restart. Okay, everything is syntactically correct, but there is some runtime error. MX plus 1. Hmm. Why do I say 8? Why do I say 8 there? Why? Why are there only 8 things? Wait, okay, 4 is not there somehow. 5 is there, 6 is there, 7 is there, 8, 9, 13, and 12. 11 and 13, but 4 is not there. 4 would be reached when I add 2 and 2. So 4 should have been there. Possible. Should have been possible. 4 should have been possible. When I was using the second, when I was equal to 3, when I was equal to 3, when I was equal to 4, when I was equal to 4, and s was equal to 4, s was also equal to 4, then this function should have called the element is 2, so 2 probability of getting a sum of 2 when we are only using 3 elements from the start. And yes, probability of getting to 4 when we are not using this current element. should have been true, should have been true. And when we were only using first two elements, this would have been pretty cool because s minus 2, s would have been 2, and to get to a sum of 2 using only the first element, to get to a sum of 0 using only the first element. Wait, is it not possible to get to a sum of, it is because of this thing. In the first row, put everything equal to true, but still it does not work. Mm, uh, I guess I will have to go to the washroom and I will be right back. Even though I have written implementation of this thing on my own with my own method, the one that I'm trying to implement is this one. Let's look at this. Possible equals false. They are not even using a two-dimensional vector, which is much more smarter than what I am doing. 10 to the 3, 10 to the, yes, yes, 10,000, 10,000. Possible. The size is this. Okay, Boolean vector, vector or array, Boolean array. And is it possible to get to a sum of 0? Yes, it is. Shit, they have collapsed. And n, c in, n. They have collapsed the vector. So when I use any coin, this makes sense. This makes sense. Okay. Vector int a size n for int reference x c in x, and then a boolean vector pos as in possible, is it possible, and 1e5, that is the 1e5 plus 1 because 0 is also something that we might want. Yep, 0 is also something, and pos 0 is true. So for int s equals 1, s lower than equal to 1e5, const and range equals 1e5 plus 1. Range and s lower than range s plus plus. For a sum of 1, I would know, yes. And for in I equals 0, I less than n I plus plus, pos s equals pos s depending on if s minus ai current sum, if I do use it, if it is greater than or equal to 0. If it is, then pos s equals pos s minus ai. Pos a minus si, s minus ai, ai. And then do they go through the vector? Yeah, count the number of possibilities, and then wait, they are not even storing the thing. They are not even storing the thing. 2, 3, 4, yes. Okay. Uh, int sz equals count pos dot begin and pos dot end, count the number of times that proof is appearing, cz out, and begin +1 because we are not going to count 0 as a correct thing, and then for int I equals 1, I less than range I plus plus if pos I, if it is possible to reach a sum of I, then output I with a space and see out a new line. That is absolutely wrong. Shit. Because I might be using the same coin again and again and again and again, and that is bad. Shit. Okay, so before I move on, I would like to go to the washroom and I will be right back in a minute. And I'm back. I feel refreshed. Okay, so we cannot do this because this is wrong. Because we are here using the same coin again and again. For int I equals 0, I less than n I plus plus, and let's say int c is our current coin. We have it here, and then for int s equals 1, s lower than range s plus plus, and pos s equal, now if I remove the current coin s minus c greater than equal to 0, then pos s equals pos s minus c. Whatever it might pos this or pos s. Or wait. I think we can use this. This might be possible here. And if we are going to do that, let's put this Above, we don't need that, and we don't need this. We need the size. Okay, so that is wrong. That is fine. We can fix that. Or pause S. Okay, that is quite a bit wrong. I have to come from top to bottom. I think I have to come from top to bottom. It's range -1, and while S is greater than equal to 0. Okay. Oops. Uh, okay, now it is working. Let's see. Submit this. It is my internet not working. It is working. That is fine. And my phone is going to die, by the way, just saying, somehow, even though it has been on charge for the whole duration. Shit, it will die. It will die. It will die. On change money sum C++ 20 and submit. And yes, accepted. That is cool. That is cool. Okay, and we can now move on to the next dynamic programming question. I have only been able to do one question in 2 hours and 30 minutes, which is very bad. Very bad. Counting towers. Okay, error description. Why am I getting, yes, because I was getting wrong answer because time limit exceeded. I'm using 1000 characters almost, which is a lot of characters. So it was array description, array description, this one. And here the time complexity, I'm getting error. Time limit exceeded, error. I think because I should not use recursion and I should use something else other than recursion. But yes, here the maximum value, it is not rendering correctly. Maximum value for M is 100. Maximum value, yeah, for N is 10 power 5. And what is xi? Xi is going to be in the range. So that is cool. I do not have to check for that. Let's change this thing. Yeah, we can change. We can change. What can we change? We can change this from a recursive approach to a better one. Right. When we have taken all of this, we are going through the array and we are seeing if we are correct or not, which we can actually see here. If I, so, and be true, let's have equals to true here. If therefore now if I and absolute difference of AI minus AI minus 1 is greater than 1, then do P equals false. And if we are doing that, we do not need this thing. Yep. And yep. Okay. And a response. What would our function be like, look like? Since we have a vector, let's define our function like this. For the ith position, we have the value x. Return this. How many arrays are possible? Now, this would depend on if it is possible to put this x value here, right? If it is not possible to put this x value here, then we cannot do anything with this. Yep. Then we cannot do anything with this. And if I equals 0, or not I, if ai, the element at index I, is 0, then we have a bunch of choices. The choices are to put it equal to 1 to m, and not just this. The choices would not arrange from this. The choices would be I will have a left and a right limit, and only fill them. Yep, only fill those possible values into x, that thing. And we can start filling values from the left. And once if I have called this recursively, how would I define this function recursively, where I is the index and x is the no, x is nothing, I is the index. So for this will depend on a few things. I equals 0 if this is the first element. If this is the first element, then it will depend on how many other elements there are. Yes. Now, if this is the first element and ai equals 0, ai, the value here is equal to 0. If the value is 0 and this is the first element, then I can have the answer would be equal to f. First, I will put ai equal to 1, then all the values till m, and I will be calling f function for I plus 1 every time. But that is bad. Yep, because I do not know beforehand. So this recursive approach seems to be right. Ark, hello, how to make the terminal like this? Can you make a tutorial on this or refer me some video? Yep. Uh, um, Here I'm using a couple of things. First of all, my terminal is Ghosty, and this is Vim. I think you know that. And then this thing at the bottom, you are seeing CSES, NeoVim, and terminal. This is Tmux, which allows me to have different sessions, and I can jump between sessions. So, yep, that is pretty much it. And for my Tmux, I do not have any configuration. I have only changed by default. This color at the bottom is green. I changed it to be blue. That is my configuration for Tmux. And for NeoVim, I have my configuration file, which is also on GitHub. And for the terminal, I am using, wait. I am using dot slash oh my ZSH. which is this thing. You can use that. Oh my ZSH. You can install that and your terminal would also look good. If you are also using ZSH, if you are using bash, I guess there are other things for that. D target CSES, yep. Okay. Anyways, I guess I will have to optimize this at some point. But for now, I would like to move on to some other question. Shit. And I'm still having a very hard time shit with these questions. I've only been able to solve two of them, and I thought maybe, just maybe, I would be on a roll and I would solve maybe half of these questions, but no, not today. Counting numbers, which one now? This one, counting towers. Let's do this rectangle cutting. This one seems to be the easiest right now. Yeah, let's be that. Given n rectangle, A into B rectangle, your task is to cut it into squares. On each move, you can select a rectangle and cut it into two rectangles in such a way that all sides remain integers. What is the minimum possible number of moves? You know what? Given an A, B rectangle, your task is to cut it into squares. On each cut, you can select a rectangle and cut it into two rectangles in such a way all sides remain integers. So if the rectangular size is 3 and 5, I need 3 cuts at minimum. The minimum number of moves. Okay. If I have a rectangle like this with sides 3 and 5, if I make a cut at this point 3, this is a square, so that is done. And here I am left with side of 2 and 3, and that is not going to work. That is going to work if I now make a cut about here in this, and size of this thing is 2 and this thing is 1 and this thing is 2. Those are 2 cuts and 1 cut here. So here the area is 1, here area is 1, here area is 4, and here the area is 3 by 3, 9. Shit, it feels like Fibonacci. Yep, it kind of is 1 square, 2 square, 3 square. Okay. For each possible rectangle, I will have a bunch of choices, 3 and 5. But do I want to make cuts like this along the longer side? Do I want to do that? I don't think that would be good. I would only like to make cuts along the shorter side. And I will have, if the longer side is of size n, then I will have n minus 1 places to cut it. Yep. So given a rectangle of sides A and B, how would I define it? What would be the base condition? Base condition would be A equals B. Then if A equals B, then the number of cuts is 0. But if not, if A is greater than B, if A is greater than B, or so yeah, if they are not equal, then either A is greater or B is greater, then we can say if B is greater, then we will flip them. If B is greater than A, we will make swap A comma B, and yeah, like this thing would happen. And now we have A is greater than B. A is greater than B. And therefore, we will call this function. We are not going to cut the B side. We will only cut the A side. 1, B. We need the minimum value. And the hypothesis that I'm going with is this, that making a cut along this side, this longer side, is not good. Yes, because I think that the number, yes, because I think that the number of rectangles that we will have to make would increase, and the number of squares that we will have to make will increase. Yes, I think that is something that would happen. So this is what we are going with. To find the minimum of calling this function I to B, where I belongs to set 1 to A minus 1, when A is greater than B. So we can write a iterative approach for this. Yes, where our table would have indices A to B, and A to B is what we are trying to find. And yep, and if we do write this in a iterative manner, then A, B should be equal to wait, why does this feel kind of bad? This will be our table, and shit, are we increasing the distance between B minus A? If we are assuming that A is the bigger one, then B minus A, if we are we increasing the length, the distance between A and B? No. Why would we want to do that? The maximum distance would be equal to A minus B. Initially, the distance would be 0. Uh-huh. You're welcome. You're welcome. But I am struggling here to solve this. Let's do this, do this, do this. Boilerplate, no, no boilerplate. Wait, in that question, the other one, array description. If I say I was sync with IO, std IO, false, do not sync, and cn dot tie null pointer, is it going to make this faster? Okay, wrong answer. Original code is gone. And also, yes, yes, yes. And if AI and AI and AI minus 1. It would be really cool if I could get this right. This one, edit description, submit, choose file, edit description, C++20, yes. Time limit exceeded. Okay, yes, okay, time limit exceeded. Wait, was I getting more time limit exceeded earlier? No, no, it is like absolutely the same thing. Nothing has improved. Nothing. Yep, nothing has improved. So let's get back to solving the question. Ah, this one, rectangle cutting. iOS sync with IO STD IO false or 0. We can write anything and cin dot tie with null pointer. And in A and B, what are their maximum values are 500. So that is really good. Wait, that is actually very good. I think 500. If I have A equals 500 and if I have, okay, for a given rectangle, let's say A is also equal to 500. This is not a rectangle, does not look like a rectangle. If I have and this equals 500 and then this also equal to 500, then I have 499 choices to make cuts here. It's like kind of like 500 and 499 choices here to make cuts. So in total, I have 1000 choices at maximum. And yes, internally also I will have a lot of choices, but at max, my table is going to be 2. Yeah, the size of my table is going to be 2500. Mm, What is 75 square? 75 square is 5625. I just wrote that, I don't know why. Uh, okay, okay. C in A and B. Tabular function. How would I write this in a tabular way? T A comma B would be equal to if minimum, okay, yeah, minimum of two things. First, if I vary this on this side, on the row side, A and B will remain intact, plus on the other side, I will have size A minus, this is kind of like rod cutting. This is very kind of like rod cutting. This, yes, where I is going from 1 till A minus 1. This is very much like rod cutting. And the other option is to keep A constant and I will go this way, plus A minus plus A comma B minus I. And here I would be going from 1 to B minus 1. And the base condition is A equals B. If that is the case, then answer is 0. Okay, answer would be 0 in that base condition. So how do I make sure that everything is filled? I can make sure that everything is filled. And plus 1, plus 1, plus 1, plus 1, plus 1, plus 1 for the cost of making a cut right now. Okay. Const in range equals 500. Let's make it 500 plus 1 just in case. And vector of vector int tab table range comma vector int range, and it will be called, we already have a name for it. And now the base case is for int I equals 0, I less than range I plus plus. Yes, and tab I equals 0, which is already there. Which is already there. We don't have to initialize. It is already initialized. For int I equals 1, I less than a less than equal to a and I plus plus. And for a plus 1 comma vector int b size b plus 1. For b equals 1 and b less than equal to, what the heck, j equals 1 and j less than equal to b and j plus plus. Shit. The time complexity is 500 into 500 into 500 into 500. 8 zeros straight away, and then 5 power 4, 125. That is a bit more than anyone could handle, I would say. What if I just make cuts along a single side and not along the second one, right? This is going to be my vector, and 3 and 5. Let's go with that. 3 and 5. 1, 2, 3, and 1, 2, 3, 4, 5. If that is the rectangle. Yep. Here the number of cuts needed are going to be 0 when they are already the same. And here the number of cuts, yeah, that is just 0. Now when I'm here, the only possible cut I can make is at this point, so answer would be 1. And for here it would be 2, it would be 3, and it would be 4. Here 4 cuts would be required, and here the answer would be 1 for this point when the side size is 2 and 3. 2 and 3, 2 and 3. I have an option of making a cut here. If I do make a cut here on this side, I am on this territory. I have two rectangles of side this 1, 3 and 1, 3, and that does not look very good. But if I make the cuts along the longer side, that seems to be better. And if I only make cuts along the longer side, that would be really good. So if I only make cuts along this side, then I will go into this row and 3 and 2. If I make a cut at, let's say, this point, and this is side 2, this is also side 2, right? And this is side 3, then I make a cut here. No, this is side 2, and now this is 1, this is 1, this is 1, this is 1. So answer would be 2 for this thing. The answer would be 2 when I made a cut at this point. So I took 0, and from this I took 1. Wait, is it just equal to the prefix sum plus 1? Wait, actually, here it is 2, and then here it would be 2, and when I have a sign of 2 and 3, it is 2, not the prefix plus 1, it is here also 2. But in this case, we are going up. Yeah, when the side increases, 2 and 4, 2 and 4, I can make a singular cut and everything would be very good, right? Yeah, answer is 1, so it is not equal to the prefix sum of the last thing. And yes, shit, my camera is gone. My camera is gone. Yep, the camera is gone. That is not a problem. I don't know why the heck, but my brain is totally not working. I do not know why. But okay, that is just an excuse. So what I have to do is when I'm here, find the minimal value, two smallest values. No. Uh, yeah, two smallest values. So when I am here at 3 and 5, the possible values that I could choose together would be this. One side is 1 and the other is this. And the other would be this. So answer in any way would be 3. Yes, for 2 and 3. And then when I am at this point, I will go along this way. When I cut it in this order, 4, I need a sum of 4, 2 and 3 and 1. So answer here would be 3. And for this point, if I make a cut along this side, we'll get a sum 0, 0, 2, 3 would be the correct answer. So, okay, that is making sense. That is making sense. And I think, yes, that is making sense. That is actually making sense. When I'm at this point, I take the smallest pair, and when I'm at this point, I take the smallest sum pair, which should give 2, and yep, and when I'm at this side, 3 plus 1 and 3 plus 1, 4 here. Yes. And when I'm here, I am making it 1. Why am I making it 1? I can like initialize can, yes, I would need all the values to the left also, so I cannot skip going through this thing. So I would see where to go to. Huh? Mm, What is the direction that I should go into? It would depend on which one is smaller, the larger one. To okay, shit. The value here depends on everything to the left, and the value on everything to the left, it depends on everything above it. So that is kind of strange. Okay, okay, I think I do have a notion as to what I have to do. If I is not, if I equals j, continue, even though that spelling is correct, wrong, continue. And yep, the camera is off, which is bad, but okay, anyways. Let me also put my laptop on charge. Okay, continue. And otherwise, if I is greater than j, then we will cut along in that direction. And if j was greater, we would cut along in that direction. Now, if I is greater than j, I is this thing, I is this thing. If this thing is greater than j, then we will find the best matching pair in the ith direction. And to find the pair, we will have for int k equals 1, and yes, while k is lower than equal to I divided by 2 and k plus plus. Since we are looking for the minimum, let's do tab I j equals int max, and tab I j equals minimum of tab I j comma 1 plus tab I am cutting along the kth direction a j, all of them are filled, plus tab I minus k j, which is the length that is left. That is kind of cool. Else we just have to change I with j. If j is greater, then do this, and at the end see out tab a comma b. Why a comma b? A is the first and b is the second. Okay, that is horrible. In the last line, why int max was not declared in this scope somehow? Okay, include c limits dot h. C limits is not a thing. LSP start client D, and C limits is not a thing. Apparently, C limits is a thing, but C limits dot h is not a thing. Okay, if I is equal to j, then skip. Otherwise, do ij equal to the maximum value possible. And then iterate, cut through the smaller side. If I is smaller, if I is greater, if we are at this point, then try to make pairs of this and this minimum pair as a initial value, or 1 plus tab k starts from 1, and on the other side we would have this thing if I is equal to 3. But the fact is that this thing would not exceed I, and that is the main point. Yes. And yes. This is also something. This is also something. Uh, Replace this with k, and here we should have I and minus k. Okay, shit. It is working. Okay, it is working. It is working. It is working. It is working. Okay, let's submit. Let's submit. Let's submit. Okay, what even was the name of the question? Rectangle chopping, rectangle cutting. Yes, cut them all, the rectangles. Yo. Okay, I am getting a few wrong answers, but everything else seems to be pretty cool. Why did I get a wrong answer here? Uh, okay, why am I getting wrong answers? Wrong answers don't make a lot of sense. Why am I getting wrong answers in these particular cases, very particular cases? Uh, because I am always cutting from the longer side. I might have to cut from the shorter side too, and that would increase the time complexity a lot. Like this would be the new time complexity. Wait, but these are in parallel. Shit, these are in parallel. So that is fine. That is fine. Yep, these are in parallel. Shit. Okay. Yep, that is in parallel, so it will work. It will work. It will work. It will work. Rectangular, uh, rectangle cutting. C++20. Let's go. And testing. Okay. That is beautiful. That does look beautiful. That does look beautiful. Yes, I might even cry. That does look beautiful. And if I were to do this again, let's do this. Taken A and B. A and B are the sides, right? And also const in range is 500, 501. 501 is the range, and when I have taken this, I will create a table, a vector, and turn off my LSP, stop a vector of vector in, it will be called tab as in table, size would be a plus 1, and end size b plus 1. A plus 1 would be the number of rows that I have, and b plus 1 would be the number of columns that I have. and everything is already initialized. I don't have to do anything with that. And I initially will be equal to 1 and will go lower than equal to a, and yep. And then for int j equals 1, it will go lower j lower than equal to b and j plus plus. And now when I am here, if I equals j, then just continue because this is the base condition. I don't need to do anything. And now I will have a bunch of places where I can make a cut. So first, let me initialize tab I j equals int max, and let me also have include c limits for int max. And now for int k equals 1, k is the place where I am going to make a cut. First, I'm going to make a cut along the I axis, you could say I plus plus, and tab I j equal to minimum of tab I j, comma, either keep the value that already is or make a cut, and tab k j, whatever the minimum number of cuts were, and tab kj, and also the other side which is remaining after I made a cut at the kj place, k point. Now let's make k cuts along the other side, along j, k plus plus tab ij equals minimum of tab I j comma 1, either this or make a cut along the current I tab I j minus k, the other side that is remaining, and whatever the case at the end, output tab a b. Only a. Shit. Why is this happening again? Int max, I am where am I even using that range value? I'm not even using that. I have a plus 1 number of rows and b plus 1 number of columns. If I equals j, then continue, do not do anything. Otherwise, go inside, put I tab ij equal to maximum value of integer that you could have, and k equals 1 till k is less than equal to I by 2. And k is the place where you are making this cut, and find the minimum. Okay, what even is the error? Some error related to vector, maybe a seg fault, but yes, I should not see a seg fault here. Like, why would I see a seg fault? Tab ij, because I and j are within the range, completely within the range. The range, there is nothing bad with them. For int I, for int k equal to 1, the place where we are going to make our cut. And yes, well, still there is some error. Still, ij minimum, either keep it as it is or make a cut along the other side. Well, I literally cannot see what the mistake could be. If I equals to j, then continue. That is correct. And if not, then tab ij equals maximum value that it could have. What is this? What is this? I am taking in a and b That is one thing. Uh, and here reference include, wait, there is some mistake. Still vector allocation. There is some mistake with allocation somehow. Tab A plus 1 and I B plus 1. Yes, the syntax is LSP start clang D. LSP saying there is nothing wrong. Okay, LSP has gone through everything, and the LSP is saying there is nothing wrong with this. A vector of integers. A vector of integers tab ij, find the minimum value. Initially, they are maximum. And yep, shit. K is not going to be equal to 0. That is also one thing. But there is some other mistake or the hell. Tab int mx equals a into b. Let's just say that tab equals mx. But I don't think that was the error. Yeah, that was not the error. Minimum value of this thing tab ij plus k. What even could be the mistake here? Shit. Shit. That. Okay, that was a very stupid mistake. Choose the file. Rectangle cutting. C++ 20. Yep. Pending testing and ready and accepted. Okay, that is cool. And for today, that would be the end of the stream because shit, I thought I would be able to do a lot more questions than this. I only did 2 questions. This one, money sum, and then a rectangle cutting. Yep, only these 2 questions. I think it is still better because at some point I was struggling with this question, which has been done by 48,000 people. And today I did this question, rectangle cutting, which has been done by around 28,000 people. And but a few days ago I did this question. Okay, it is, yeah, I think this is not a very good indicator of how difficult a question is. It is more about how my maths is not good and I do not have much experience. Yeah. Yeah, yeah. So I'll be solving questions of the stream also, and that would be nice. Okay, and for today, that would be the end of today's stream. And thank you for being here. Bye. Even though you cannot see me, the camera blew off. But anyways, bye. Thank you for being here.